Welcome to the, I think we're in week 3 now of the Encode Filecoin Club, where we will be looking into the depths of Filecoin and teaching you everything that you could need to know about the Filecoin ecosystem and how to get involved. This is part of a 3-part kind of program overall, involving this education series, which will run through for a number of weeks now. I think we've got 12 events in store for you. And then we move on to a hackathon in October. After that, dedicated Encode Filecoin hackathon for you to build over 8 weeks, whatever ideas you want to build. And finally finishing up with a nice accelerator for those best projects to help them become startups within the Filecoin ecosystem. I'm delighted to have Michelle Lee with us here today, who's going to teach you all about actually Filecoin, ironically, because whilst there is many things to talk about, Filecoin actually is the subject of this whole program, so particularly kind of apt presentation today. So Michelle, we're very pleased to have you back, and over to you. Just a word on etiquette, everyone. If you have questions, please put them into chat. This event is recorded and will go up tomorrow morning on YouTube and Medium for consumption thereafter. So Michelle, over to you, and thank you very much for your time this evening for me, probably this morning for you.
About lunchtime on.
Okay, as I said that, I cringed.
But you know, we make you guess, so yeah. Good guess. Well, hi, thank you so much to the Encode team, as well as to everyone who's joining here today. My name is Michelle Lee. I also go by Mosh on various internet platforms, so happy to be called by either one. I've been working on IPFS and Filecoin for the past handful of years across all sorts of teams, typically bridging between users and engineers. Currently, I spearhead our developer onboarding team, which consists of an advocates group, our grants program, and also our collaborations with other Web3 systems. Before we get started, I'd love to hear from everyone. Just drop a note in the chat if you can, what you had for breakfast today, and also one thing you'd really like to understand about Filecoin from this talk. I have slides, but I think that'll really help me make sure I hit on some of your big questions. All right, Nutella toast, and what is the future of Filecoin? Maybe anything that has been confusing from the okay, how does Filecoin interact with IPFS? I had croissants this morning with jam. How exactly does Fill Plus work? Okay, great. How does Filecoin address the speed issue? Okay, fantastic. Well, I will check the chat periodically, not constantly, for questions. Ryan Bauman or Discordian may be able to answer in between. If I don't get to your questions during the talk, I'll make sure to save time before we finish for that. So, all right, well, why don't we get started? What I want to cover with everyone today is definitely the relationship between IPFS and Filecoin, some of the core concepts that make Filecoin work, and then also what you can do with Filecoin as a foundation for Web3. We won't go really deep into cryptography or economics. We don't have hands-on tutorials as part of this session, but there are lots of resources available, either as future sessions of the Encode Filecoin Club or just independent resources that I'll be sharing some links to soon. Okay, so a few weeks ago, you heard from Hector Sanwan about IPFS, which stands for the Interplanetary File System. Big misnomer, it's not a file system. I would call it a storage system, though, that's distributed with no central server, it's resilient. And the idea is that we can build a new web that's not beholden to centralized entities and also has a lot of efficiencies in new ways to approach data and content. One of the big themes there is the peer, right? So peer-to-peer networks, instead of dialing a central server or going to a certain location to access content, instead, all these independent nodes are able to connect with each other, figure out what data they have, maybe fetch it across the swarm, and connect in ways that, that are more holistic, more decentralized. The other big concept there is content addressing, which hopefully folks have heard of before if you were at the talk a couple of weeks ago. If not, it's the idea that any data in the world can be run through a one-way hash function and output a unique fingerprint that is unique to the data that it's created from. So if you put in a picture of my dog, it's going to output a different fingerprint or content ID, if you will, than a picture of your dog. And these content identifiers are really special because they allow us to fetch or compare or ask for content across the decentralized web. We don't really care about file names or where it's stored. If someone has the content, we kind of know with high confidence, with absolute confidence, that CID points to a certain piece of data. So if you combine these two concepts, I think those are kind of the magic building blocks of IPFS. When it comes to using IPFS in the wild, though, and we say we have this magical cloud of nodes, who's actually running these nodes and why? So one option is you can run your own IPFS node, and that's what happens if you're running the IPFS companion. It's a Chrome extension. If you're running IPFS desktop, or if you're running something in the browser from your browser app, the problem is if you close your laptop or your computer goes offline, then we lose that connection to the decentralized web. So the web can no longer access you, you can no longer access the web. So that would be too bad, right? A second option is you can hope your content or your data becomes popular enough that other nodes are going to pin it, like the Olympic mountain bike race from this morning. Probably my next door neighbor also has it, could fetch it from him. But this is like a strategy of hope, and it's not really a strategy to build an application on, or an internet on, right? And so this can gain us some efficiencies, but it's not a system we can count on. So the third column is you can run your own network of nodes. And this is what happens most in most of the production uses of IPFS. So IPFS users set up nodes, in different geographies or in different configurations, depending on what they need. And they use this peer-to-peer protocol to connect to those nodes and fetch data. So you might have researchers with, huge piles of earthquake data in Hawaii and Japan and Taiwan, all collaborating on the same database for earthquake data, and be able to access it through content addressing, be able to access certain subsets of that data through content addressing as well, across this global network. So that's great, but you need to manage these nodes, and that's work, that's time and effort and people power that could be better spent working on your research or working on your data sets, right? So that's certainly an option today. Another option for ease of use is that people will often pay a pinning service to pin your content on their nodes. So there are several companies in the Web3 space that specialize in, specialize as pinning services for IPFS. Pinata, Temporal, and Fura are some of the names. And basically, it acts a lot like any sort of business that stores data for you. You pay them, they pin content for you, and it's then available to the decentralized web. But what if you wanted the benefits of all of these? What if you wanted to not make contracts with any company at all, but you also wanted the ease and reliability of a storage network? And so that's where Filecoin comes in. Filecoin, you can think of it as the incentive layer for IPFS. And if I were to start from scratch, here's how I would design an incentivized storage system for Web3, right? So with IPFS, you're either paying a service or you're relying on goodwill for peers to pin content. With Filecoin, that introduces the ability to have the network broker deals and ensure that content gets stored. So the first thing is I would make sure it's compatible with IPFS and Web3. So I'll go into more detail about this later, but Filecoin uses the same exact content formats as IPFS. So you can, if you store data to either network, you can fetch it back using the same CID. We're also building integrations with other Web3 networks like Near and Hedera, essentially a lot of the smart contract platforms, because smart contract platforms are designed for lightweight transactions and interactions, but they don't really have a way to store larger amounts of data in an efficient and cost-effective way. So the first thing is I would make sure that the storage network is super compatible with IPFS and smart contract platforms. The second is the big question. If you don't want to trust a single company, how do you prove that you're really storing my data? How do I make sure you're keeping your promises? How do I penalize you if you lied or you made a mistake and you no longer are storing my data? So how do we enforce this? And Filecoin has a set of cryptographic proofs that I'll talk about in a moment that combine the forces of the network to prove and continuously prove that data is being stored. The last thing is I would make it really, really big because the bigger the decentralized network, the more multi-party it is, the harder it is for one entity to take over. So this network is governed entirely by consensus, by computer algorithms, instead of any single corporation. Okay, so we have this incentivized storage network. How does your data actually get onto the network and make it into this incentivized storage system? So first, you or your application makes a deal with a provider to store your data. It's essentially just a small transaction that you negotiate back and forth with the provider. They say, hey, I can store this amount of data for this price. If you say yes and you send your data over and some payment, that turns into a storage deal and gets that's published to the chain. So on the left, there's a little bit of an illustration that's faint, but in the process of sending your data over to the storage provider, it actually gets packaged or transformed into a DAG, just like an IPFS. So the resulting CIDs are exactly the same, whether you're storing to IPFS or to Filecoin. Once the storage provider gets your data, they generate an initial proof of replication. This is computationally pretty expensive, so it's very hard to fake or spoof. And then that's part of the storage deal that's published to the chain. Over time, providers have to keep proving that they still have your data, but they do this through kind of selected subsets of your data. They don't have to run the same computations over all your data at the same time. That would be really expensive, resource intensive, environmentally bad, all sorts of things we don't want to do. So for ongoing proofs, those are managed by proofs of space-time, and these are proofs over smaller subsets of data. And if they continue to submit these correctly, then the providers are paid incrementally for keeping up with the deal. So you can, because of these proofs, you can actually check the chain for proof that your data is being stored and stored correctly at any given time. You can, and if it's missing, you can also look back in history to see when it went missing or when it was corrupted. And you can get your data back by making retrieval deals with these same providers. So this storage flow is how it works at the protocol level. In terms of actually using it to build your apps, there's a number of storage helpers and simplifiers that I'm going to talk about that turn all of this stuff into one API call. But I think a lot of people want to understand how Filecoin works from the ground up, and so that's kind of an explanation of how it works under the hood. Let me go back to the chat for a little bit and see if there are any questions I can answer real quick that Ryan hasn't covered. Okay, I'll keep going for now, and I'll come back to questions in a few moments. So this is Filecoin. You can think of this layer as the incentivized layer. IPFS is what allows for really fast, flexible retrieval. It's been around for, I think, almost 6 years at this point. So there are all different ways to access IPFS content now, browser extensions, local nodes, also gateways that will translate a Web2 address to a Web3 address. There are browsers like Brave that actually support IPFS natively. So lots of different ways to retrieve your data through IPFS. And then Filecoin, I call it the layer for persistence and verifiability. So if you want guarantees on your data, also stored in Filecoin. So and this speaks to what I said earlier, where Filecoin is both a protocol and a network. The protocol is kind of like the guts of the mechanics of how clients and providers talk to each other, negotiate deals, what actually gets stored on chain. In reality, and that's the darkest blue circle here, the core protocol implementation. But around that, we have layers that are intended to make it a lot more approachable, a lot easier to use. You can even store stuff to IPFS and Filecoin in a single call. And that's the focus in terms of people, that's what we also want to emphasize for folks who might be considering building on these systems is your application doesn't actually have to negotiate storage deals or wait for the chain to return a certain verifier to you. That's all handled in the background. There were a few questions on numbers of miners. So this is from Philfox, which is one of the network dashboards. There's a handful of them available that show a bunch of stats about the network. Someone asked how many nodes there are on Filecoin. Right now, there are 2,756 active mining nodes. It's in the upper right. We're close to 1 million blocks on the chain. New blocks are created every 30 seconds. So that's, since last October network launch was when the block count began. There are some questions on how do I run a Filecoin node? There are 4 implementations of Filecoin. If you want to run a node and be a provider, you can run a full node. If you want to run a node and just submit messages to the chain, you don't not do any of the proof work, you can run Filecoin Lite, which is a lot easier, simpler, less resource intensive. The instructions for running a node are on docs.filecoin.io. Hopefully that answers that question. How does randomness work on Filecoin? Okay, this is a great question because randomness is part of the proofs that you have data at a given point in time, right? You combine you combine the static information, your data, and then you combine these. You add these random seeds from an external source, and that creates a unique situation where you're never going to have that random seed come out exactly the same at any other point in time, right? The randomness comes from a network that's also decentralized, which I think is really cool. And it comes from a network called DRAND. DRAND is a distributed randomness beacon. Basically, I think a dozen parties contribute randomness seeds. Those are all combined to output a single randomness beacon, which means that no one party can hack this either. If you take over Protocol Labs, there's 5 or 8 other institutions that are also providing randomness seeds to this service, and it outputs a truly decentralized random number. DRAN.love is the website. Couple questions. How do you prevent illegal content being stored, especially if encrypted? Okay, so HTTP is like the web protocol we know super, super well. HTTP doesn't inherently prevent illegal content from being passed over it. However, HTTP servers or Web2 hosts have policies that prevent or deny illegal content. And that's the same for Filecoin and IPFS. So the protocols themselves, like the sort of highways, don't have any, you can't really restrict content when you build the highway or when you build the pipes, but you can restrict content based on different policies when you send it through, like when you pack it into IPFS or Filecoin, the equivalent of putting it on a truck. Storage providers have an option to provide a deny list, and then we have a network that will keep track of content that's reported to be in violation of different policies on the deny list. Providers can check against it and advertise their deals as saying, hey, I only accept content that applies with the EU's content policies, or I only accept content that applies with American content policies, etc. How does governance work on Filecoin? So if you're talking about consensus, the consensus is formed by all the miners. We have a set of processes called actors that run, continuously and then check on the various contracts, deals, storage proofs, and make sure that those are functioning correctly. If not, the providers can get penalized. If you're asking about the network governance, major changes are introduced through the FIP, the Filecoin Improvement Proposal process. Drafts are usually posted on GitHub. People have a chance to comment, and then the stewards team votes on and adopts them. What grants are available for building with Filecoin? I am so glad you asked. That's a great question. GitHub/Filecoin project/dev grants has a list of the grants. I think there are two major types of grants. One is open grants, and that is for concrete projects. You have a proposal. The budget range is usually between $0 and $50,000 equivalent in USD. And at the end of it, you have something that you're really proud of that we think can move the ecosystem forward. So it can be an independent project, it can be an advancement to the protocol, it can be a developer tool, it can be adopting Filecoin into your existing project. The sky is open. And there are also some specific topic areas with RFPs that we're particularly interested in. So you can apply for either an RFP or an open grant. And those are more typical grant projects. We also have a micro grants program that is intended to encourage any independent developer to take the next step after building your initial prototype. So if you've built anything, any MVP or proof of concept, and you want to keep going, I would love to see you all apply for this microgrant program. We review every single week, so the turnaround time is very fast. The criteria is very straightforward here, and all the info is in the dev grants repo. Just search for microgrants under that program. Let me go back to here, and we'll come back to more questions at the end if there's time. So I talked about this, decentralized storage layer. That's, this stuff at the bottom. On top of that, we have storage helpers that are, they're either SDKs or hosted APIs or ways to simplify building with Filecoin. On top of that, you can have, application logic, whether it's just, very straightforward logic locally in your application, or smart contracts that, send information or state to another decentralized network, and then get back the result of the determination of the smart contract and incorporate it into that app. And then of course you also have the front end. So I kind of went backwards from bottom to top, but this is a pretty standard application architecture. And you can see at every single layer, you have options to use Web2 technology or Web3 technology. Here is an example. So it is possible to build an app that is Web3 or decentralized at every single layer. So you can have an application that asks your browser for a CID. That CID, if your browser speaks Web3, or if that's a URL that speaks to a gateway that translates it to the Web3 address, you can get all the content for your front end, the JavaScript file, the HTML file, the Markdown file, whatever it is, that can all be loaded from IPFS. If your app needs a login, you can log in with a DWeb wallet like MetaMask. If your app needs application data stored or object data stored, you can use a storage helper and then put that, get that data onto IPFS or Filecoin. So this is one example. It's probably one of the more decentralized application architectures you can have, but it's one example of how you can build on top of IPFS and Filecoin all the way up for your web app. One of the easiest ways to get your data onto Filecoin and IPFS is Fleek web hosting. So it connects to your GitHub repo, and you can set up GitHub actions to deploy super easily. you basically don't have to touch IPFS or Filecoin at all to use Fleek. What it does is it runs a GitHub action, it deploys your site onto an IPFS node, provides a gateway address, and it also backs up to Filecoin. So, I think this is an interesting tool to try out. It's kind of a one-stop shop in that once you get the hosting up and running, there's not too much more you can do to experiment. So if you want to build some applications or decentralized apps that use storage on these networks, like I mentioned before, really, really recommend using a storage helper. It simplifies all that diagram stuff that I shared earlier, and you can store to both networks with a single call. So you get the benefits of fast retrieval that's really flexible, but also this persistence and verifiability. A couple of the tools you can use to build, if you're building desktop apps, the Fleek Space Daemon is a really great option. It combines all this stuff into a background service. It basically puts these nodes on the user's desktop. It can be bundled with the desktop app. You can call it with a gPRC API, or you can use a JS client. So docs.fleek.co is where you can access that. Estuary is a really great option for storing to both Filecoin and IPFS at the same time. It makes the deal making and verification steps really seamless. They also have a web interface for this. And so you can see like the green and blue steps. The text is too small to read, but it's basically, green is showing active deals, blue is showing, pending deals, and they have a lot of tools for checking on the status of your data. So that's pretty neat. And it automatically stores with 6 storage providers around the world through Filecoin. They have great docs. They also have a really friendly and active help channel with the core, the team is constantly in there answering questions. So if you want to try it out and you have you want to know more, hop into the docs here, and then from there, I think it links to the Slack where you can ask questions. If you're building anything NFT related, this is a great option too, NFT.storage. It's a free storage service for hosting NFTs and their metadata. All you do is upload your data, get back a CID. Storage and retrieval is free. It's pinned on IPFS 3 times. It's backed up to Filecoin 5 times. And the docs are really fantastic. There's a JS client library, and you can see all the calls like right in there. You can also use it if you're using IPFS. You can also configure IPFS to use NFT.storage as your remote pinning service, so it can be bundled into your IPFS app, which is pretty neat. And then last but not least, PowerGate. PowerGate is true to the name, it's a pretty powerful way to connect and extend these technologies. It's a Docker container wrapped around an IPFS node and Filecoin node. I'd say that the setup is a little more complex, but it gives a lot more options. Specifically, this team has been working really hard on building bridges to Near and Polygon and some other smart contract platforms. So that could be a really great option if you're building more integrated Web3 apps. So that's a tour of some of the storage helpers. If you remember one thing, it's this diagram again. It's that IPFS and Filecoin form a decentralized substrate or a set of decentralized building blocks that can be a foundation for all different kinds of Web3 apps. And happy to talk more about those either right after this talk or in our chat channels. If you want to keep learning about Filecoin, this is a really cool interactive tutorial at proto.school. It walks you through a lot of the specifics of how data gets stored and transferred, how these proofs are generated. I saw someone ask about that in the questions. Fill.build is our new resource where we're trying to make it really easy to find different resources to build these Web3 apps. So that's a great website to get started on. Of course, there's also the Filecoin documentation. This reference page lists all the options I talked about, but it's got a lot of explainers and tutorials for different things. And I think it focuses more on the protocol itself. So if you're looking for storage helpers, I would recommend fill.build as a shortcut. And then, people often want to know more about the internals of the Filecoin economy, how payments work, how can storage be so cheap or how can it be free? And that's all covered in there. And the Filecoin Slack has a Phil-Builders channel with lots of friendly people. We'd love to chat with you more about what you're thinking of building or what you want help building. And like I mentioned, the microgrants program is here to support your independent projects. That's it for slides. Let me go back to the chat again and see. Okay. Lots of questions about how Filecoin compares to Arweave or Swarm or Sword or Filecoin. All of these are decentralized storage networks. I think, from our team, our perspective is that we want to make the most modular, the most flexible, most powerful building blocks on the web. And so what we've tried to do is make it really easy to recombine Filecoin and IPFS in any sort of application. So these bridges to Near, these bridges to Hedera, these ways of combining IPFS and Filecoin, of using them for application data, also using them for front-end storage. I think that's probably one of the biggest advantages of a system like Filecoin. It's part of a whole decentralized web stack rather than a single project. Is your data replicated or stored by a single miner? The way the protocol is designed, all your deals are with a single miner, also called storage provider. But all of these storage helpers, these SDKs, wrap it around, wrap some ergonomics, wrap some helpful stuff around that. And we know you never want to store just one copy. So most of these storage helpers store 3 copies or 5 copies, or PowerGate lets you configure how many copies you want. So when you're storing to the network, you have the redundancy there. Could you build a decentralized database to replace your regular SQL or NoSQL counterpart? I think OrbitDB, which is built on top of IPFS, may be able to be used with Filecoin. Ryan speaks to that a little bit. We should talk about that. I'm looking through the questions. I think I'm all caught up, but if there's any more, please do jump in.
Yeah, let me just check as well. But I think you've pretty much addressed, or yourself or Ryan has addressed most of the questions in there. Yeah, there's a question on the languages, and Ryan said it mainly Go and JavaScript, but also a bit of Rust. I've seen a lot of different projects starting to use Rust as well now in the space. And did you answer the question on whether Filecoin only works on Ethereum?
Just going back to the languages, there is a Rust implementation of Filecoin, and then Rust is also used in the Go implementations for the proofs components specifically, because it's so performant. So there's, if you're a Rust lover, go find the proofs team. But the majority of kind of developer tools are in either JavaScript or Go. You said, and what was the question about Ethereum?
Yeah, someone said, does Filecoin only work on Ethereum?
Okay. So Filecoin and Ethereum are 2 separate projects. Ethereum is, the tagline is it's the world computer, right? And Ethereum specializes, Ethereum and Filecoin each have separate blockchains. Ethereum specializes in transactions or smart contracts, if you will. So Filecoin can be used as a storage layer for Ethereum contracts. Like most of the smart contract platforms aren't designed to actually store data on chain, that would get really, really expensive. Because one thing we know about blockchains is that to have secure consensus, you want to do a lot of calculations or verification for each block across the network, so that no one party can take it over, right? So Filecoin's storage systems kind of compress your data, turn it into CIDs, and they pack it even further using these this like proofs invention called SNARKs, zero knowledge proofs. And anyway, it compresses your data into generates a very small fingerprint, I guess I would say is the best metaphor, out of your data, and puts that on chain. And then it also stores, the providers are storing your full data, and then only the fingerprint goes on chain. And that's something that most smart contract platforms don't provide. They don't have a way to keep your original data and keep the footprint on the chain very light. So Ethereum is one example. I think like Hedera, near a lot of these other chains as well, where they're really great for transactions, for smart contracts, and Filecoin can be used in a complementary way for storage. How energy efficient is Filecoin? We have a big project about that coming out really soon. I think we're calling it Green Filecoin. I don't know what it will be called when it's released, but it's an in-depth analysis of energy consumption of Filecoin. It was designed from the start to be a lot more efficient than proof of work. So in proof of work schemes, you're basically just a big rat race for which computer has the most computing power and can do the most calculations to come up with the winning block. With Filecoin, it's a proof of it's a modified proof of stake scheme where the more storage power you provide to the network, the more likely it is that you're going to win the next block. So you're providing something useful to the world, and by providing more of that stuff, you're more likely to win a block. And so the concepts are designed to be much more energy efficient. You're not constantly running computations in order to win a token reward. How fast is Filecoin? That is a great question. So speed and security, I think, are this triangle. Speed, security, and energy consumption really are this triangle that you are constantly playing with if you want a secure, decentralized network. And so we've designed Filecoin to sort of triangulate between these aspects. So storing, when the provider gets your data and it generates that first proof of replication, I'll be honest, it's not super fast. But that's why all these storage helpers have a 2-layer scheme where it's stored to IPFS for faster retrieval. And then it's also stored to Filecoin as sort of a backup. So you can think of Filecoin as a cool layer, like not a true cold storage layer, but a cool layer that makes IPFS more reliable. Are there any layer 2 solutions for Filecoin from Codebreaker? Do you mean layer 2 as in the like W3C definition of layer 2, or just like one layer higher than Filecoin? If it's the latter, then I would say all of these storage helpers. Yeah, exactly. So I'd say that's all of these storage helpers. If you're building an application on Filecoin, you should be using one of these great layer 2 options. So Estuary is one. It writes to both. NFT storage is another. It's designed for NFT specifically, and PowerGate. All of these are really great layer 2 options that make building on Filecoin much easier. Yeah, and a very similar, so NFT storage is evolving and adding a product called Web3-Storage that works in almost exactly the same way, but it's not limited to NFT data.
Awesome. Well, I think that's pretty much all of the questions. So thank you very much, Michelle, and also to Ryan for helping out with the questions in the chat today. It's a fantastic presentation. And just coming up next week, we have the intro to IPLD, So I've just put the link in the chat there for everyone to go and sign up to continue in the series. And as just a reminder, this whole education series is leading into a dedicated Filecoin hackathon, which will be in October. So yeah, thanks everyone for coming, and thank you very much, Michelle, for the fantastic talk.
Great to be here. Thanks, everyone.
Bye.